Hello engineers, welcome to STA Simple channel. Today we are going to discuss about virtual clock and what is the use of virtual clock and is it cannot propagate through clock tree. A virtual clock is a clock. It is not connected to any pin or port in the design. Used only as a reference clock for timing analysis, mainly used for in-output timing constraints. The example command is create clock hyphen name clock 1 hyphen period 10. Here we are not giving any port or pin in the command. We have not mentioned any pin. So the tool treats it as a virtual clock. Here you can see a virtual clock is a clock that exists only for timing reference and is not connected to any port or pin in the design. STA tools use this clock to define input and output timing constraints when the actual clock source is outside the chip or block. In block level STA, the block we are analyzing may receive data from another block. The launch clock of that previous block may not exist inside the current block. To model the timing of that launch clock, we create a virtual clock and use it to define input delay constraints. Here you can see in block level STA, the block we are analyzing may receive data from another block. Okay, so in this example, block A launches data using clock 1 and the data goes to block B. But block B internally works with a different clock called clock core. Since the launch clock from block A is not present inside block B, so we create a virtual clock to represent that launch clock. Launch clock. Then we use that virtual clock to define the input delay for the data coming into the block B. So we are creating the virtual clock to model the launch clock. So coming to the virtual clock constraint. So in STA we define input or output delays relative to the virtual clock. So this tells the tool when the external device launches or captures the data. When will be like when the external device launch or when the captures when we have the device capturing the data. So here we have clock 1 hyphen period 10. So clock 1 is a capture and launch internal clock is clock core. So for input delay, the launch clock is the external clock and the capture clock is the internal clock of the block. For output delay, the launch clock is the internal clock and the capture clock is the external clock. So when we have to apply IO constraints, so we have to use this two commands like set input delay and set output delay. So here we are mentioning the at which it will be capture or launch and hyphen clock 1 and we are mentioning core in and core out ports for the block. So this means the data timing is measured related to the external clock. When we are creating the virtual clock, the tool will give the warning. So the warning is TCLC MD 1142. It is in Tempest cadence. So virtual clock is clock 1 is being created with no source object. It means like clock has no port or pin, so it will be understood as a virtual clock. So if it is intentional, it will ignore the warning. So when a virtual clock is created without any port or pin, it will give the warning. Important property of virtual clocks. Virtual clocks are always like a ideal clocks, and it cannot propagate through clock tree. So example warning is clock waveform, clock one cannot be propagated as this is a virtual clock. So the reason is no physical clock network exists. So as in real time, one of my friend attended the interview. So he got this question: when do we use the virtual clocks? If it is not present in the design, what is the use? So um, the answer is we have to use the virtual clocks when the clock launching data is outside the design or block used for in-output timing constraint, and it will modeling the external device timing. So in one line, we can say virtual clock models external timing reference for IO path. So we can say simply like we use virtual clocks when the clock launching or capturing the data is outside the block or design, and we need a reference clock to constrain input and output timing. So that's it about virtual clock. And if you want more info about virtual clock, so you can see the video of IO budgeting in my channel. So uh, thank you for watching. Please subscribe to the channel. Thank you. Bye.